perfectly circular orbits, you know, egg-shaped a little bit, but amazingly good orbits. And the planets themselves are amazingly round. The moon, for instance, is just almost perfectly a round ball. It is spinning so slow, there's very little bulge at the equator. The Earth is spinning a lot faster, and there's about a 20-mile bulge. The equatorial diameter is 20 miles farther than the polar diameter. If you spin a basketball real fast, it'll flatten out like a frisbee. You'd have to get it really fast. But the Earth is spinning once a day, which flattens it out a little bit, pulls the poles in, sucks the equator out, about a 20-mile difference, which really is nothing compared to 8,000-mile Earth. You know, from space you can't see that 20-mile difference. The moon is, I don't know what it is, like 1 or 2 or 3 mile difference. It's very little. The moon is spinning once every 29 days. It also goes around the Earth once every 29 days, which is why we never see the other side. As it's turning, it's always facing us, you know. They never see the other side of the moon unless they go out there and take a picture with a rocket or something. But the moon is going around the Earth once every 29 days. The moon is almost perfectly smooth. The theories of how we got the planets and the moon all fall apart. There's the most common theory, I think probably the most common theory now, is called the accretion theory. They will say the planets formed after the Big Bang, all these particles flew out, and then they all started drawing together because of gravity, and the more mass you get, the stronger gravity becomes, and they start sucking in particles, and pretty soon, you know, you got a planet. Well, you'd have a clump of rock stuck together. What's going to cause it to melt into this perfectly smooth ball? And so their answer to that one is, well, meteors hit, this supplies heat and energy. And that's what melted it. Well, there are some marks on the moon, but the moon is in an almost perfectly circular orbit around the Earth. And it's almost perfectly round. I mean, I don't think that's going to form by an accretion of particles over billions of years. Now, if you want to believe that, that's fine, but that's not science, that's religion. That's what they believe. And that'll be their answer to this one. But the moon goes around the Earth, but the moon is gradually getting farther away. We're slowly losing the moon. It's leaving us. The numbers vary. Now, people argue about this. There's good articles about this here. The impact article from Institute for Creation Research. If you want to get some fascinating reading, these little impact articles, they're just one-page articles. They're 10 cents a piece, and they started them in 1974, I believe. And they're up to number like 350 now. So for 35 bucks, you could get all of the back issues. And it is just amazing reading. I mean, that's an entire course in itself, just reading all the impact articles that they've put out for the last 25 years. This one is impact number 110, published in 1982, August of 82. And you can still, I think you can get some of these on ICR's website, icr.org. But they go through, by Thomas Barnes, was a University of Texas, El Paso. I've spoken there twice, done debates at University of Texas, El Paso. Matter of fact, recently, last month, yeah. He was a physics professor there. He was a young Earth creationist. And they didn't like him because they didn't want a University of Texas professor who believed the Bible. They tried all sorts of things to, you know, ridicule him. He's now, if he's still alive, he's probably in his 80s. But I've talked to him a couple times on the phone. Really gracious man. He wrote this article 20 years ago about the young age for the moon and the Earth, showing that because the moon is getting farther away, that means obviously it used to be closer. Now, if you bring the moon in closer, you create a problem, because the moon is what causes the tides. Now, I don't worry about the tides here, even though I'm in Pensacola, because we're 60 feet above sea level. But the folks along the beach worry about the tides, right? I've been to the Bay of Fundy, and where the greatest tidal change, were you there too, weren't you? The greatest tidal change ever recorded during what's called a spring tide, when the moon and the sun both line up, and they're both pulling on the water. It was 103 feet. We got to see the second highest tides, which is where Anchorage, Alaska is, which is where it got its name, Anchorage, a good place to anchor. But I forget the name of the bay now, but it goes up and down. That's the second highest tides. Generally, the world's tides, I think, probably average around 3 or 4 foot tidal change, from high tide to low tide. Pensacola here, it's not even that. It's probably only 2 feet. Very small tidal change. Other places, it's 50 feet. But the moon is causing these tides. As the Earth is turning under the moon's gravity is pulling on the water. This creates a squeezing effect. On the sides of the Earth, it squeezes in, and it pulls the water up on one side, and because of the squeezing effect, it pushes it out on the other side. So you actually end up getting a high tide on the opposite side from the moon. But the high tide on the other side is not quite as high as the high tide on the near side. if nothing was moving, just the Earth spinning, you would get a high tide every 6 hours. Or you'd get a high tide, 6 hours later you'd have a low tide, 6 hours later another high tide. It would all be real nice every 6 hours. But because while we're spinning around, the moon is also moving. And so you have two motions to consider. So the average is every 6 hours and 25 minutes you have a tidal change. Because in 6 hours, the moon has moved 25 minutes worth in its orbit around the Earth. Who cares, right? Okay. The point is, if the moon were closer, the tides would be higher. And we'll finish this one thought here and close on this. There's a law in physics called the inverse square law. And I want to put this on the quiz. What is the inverse square law? Be able to explain this. If two objects are attracted to each other, how strongly do they pull each other? Two magnets, let's say. If you get the magnets half the distance apart, you take the fraction 1/2, inverse it, and square it. It's now 4 times the pull. If you brought the moon back into 1/3 the distance, you take that fraction, 1/3, inverse it, that means flip it over, and square it. It's 9 times the pull. When you're measuring how bright a light is, my dad was an electrical engineer at Caterpillar Tractor Company. He was showing me all these charts and graphs they use. You got a bunch of people in the office, how much light do you want at the desk for the guy to work? Then you got to figure out how far away is your light on your ceiling, how many candle power does it produce, because if you double the distance, let's say I'm 5 feet away from that light, and it looks to be as bright as 100 candles. If I went 10 feet away, it'd only be as bright as 25 candles. Inverse, I think that's the right number, is that right? Inverse square? I have to do my math on that, but it would drop off as logarithmically as opposed to linearly. As you get closer to the light, you half the distance, it's 4 times as bright. You half it again, it's 16 times as bright. The inverse square laws, I will cover that in video number 6. They apply when you're dealing with forces involving magnets, gravity, light, and girls. When you half the distance, the attraction is quadrupled. A lot of guys don't understand that till it's too late, and we'll get into more of that later. But this inverse square law says if the moon were closer, the tides would be higher, much higher. The problem becomes worse the farther back in time you go. So the evolutionists have tried to answer this by saying, well, you don't know that the moon has always been moving away at the same rate. Good point, I don't. We do know it was closer. And if it's getting farther away, it used to be closer as you go back in time. This does put some kind of time limit. We cover in here evidence from space about the moon. This is which number? Number 5, page 11. You can get more information on this from source number 3, Scott Hughes, The Collapse of Evolution. Number 6 is Dennis Peterson, Unlocking the Mystery of Creation. And number 11, Walter Brown's book, In the Beginning, about the moon. Okay, back up one slide. So I'll ask you to explain what is the inverse square law. That's the law that says as an object gets closer, the gravity increases, the pull, the force of the increases as the inverse of the square of the fraction. That's not a good way to phrase it. Let's just say it like this. If you half the distance, it'll quadruple the traction. If you bring it into 1/3 the distance, it'll be 9 times the pull. And what phenomena does the moon cause on the Earth? The tides. Put that down. Heidi's a quiz question. Also, actually, the moon causes what's called a land tide. As we turn under the moon, Pensacola lifts up about 2 inches. The entire city. We don't notice it because all of Florida is going up 2 inches. You know, goes up, goes back down. Called a land tide. Now, if you get a land tide going up and down, this can create stresses on the crust of the Earth a little bit and can trigger earthquakes or can increase the likelihood of them happening. Pardon me?
How could you tell?
How can you tell the Earth is going up?
Yeah, how can you tell?
I don't know how they tell that. I'm sure there's ways. Get up there in a helicopter and that wouldn't work because then the air's going up too. Maybe it's just been calculated as opposed to just by the mass of the, done theoretically. I don't know that it's actually been measured. Some things are theoretical and, are logically true but cannot be proven. So that's a good question. Theoretical science instead of empirical science. Okay, so if we ask you on the quiz to name some ways to show the Earth is young, what could you name so far? Quick review. Population. I should say, phrase the question, Heidi. Name some ways to show the universe is young, not the Earth. Population shows the Earth is young. That'd be one, would count. Galaxies are spinning. That's another one. And the distance to the moon is increasing. Jupiter is cooling off. Ganymede is way too hot. And Saturn still has rings. Those are 6 we've covered, right? What's that? Tanya, are you griping or complaining?
No, I said yes.
Yes. Okay, thank you, Tanya. If you're going to be a Hovind, you have to learn to take ridicule. We get it all the time, right? We gave 6. I'll probably say name 4 ways to show the universe is young. We're going to get into a lot more. Okay? Put that as a question. They're all in the notebook, yeah.
I got them all done here, but I just want to make sure I
Yeah.
had them.
For the quiz, we'll say name 4 ways to prove the universe. I wouldn't say prove. 4 factors that indicate the universe is young. I kind of steer away from the word proof, you know. It's not a good word to use. Okay? Any questions what we covered so far? Great. Dismissed. See you next week. Well, welcome to class number 6 of our series on Creation Science 101. We're going to take a quiz over what we've covered so far from last week, and then we'll go on to some new material dealing with the age of the Earth. Let's deal with comets now. Comets are flying around through the solar system. I don't know the percentages, but they estimate that a certain percentage are made of snow and ice packed. Some are made of rock. Some are made of iron. Some are made of nickel. Some are combinations of all of the above. They can tell what they are by what color they burn, if they burn into the atmosphere. Just flying around, though, as they get closer to the sun, the solar wind begins to blow a tail off. It begins to melt pieces off, and the tail flying behind the comet is actually fragments of cometary material, which means they're constantly losing some of what they have. Estimates are that a comet can last about 10,000 years. Now, there are 2 kinds of comets. They're called short period comets. Those are ones that come around and they can predict when they're going to come back. Halley's Comet, for instance, is probably one of the most famous short period comet. So there'll be a quiz question. What 2 types of comets are there? Short period are, they come around once, come around again, in some are 3 or 4 years they come around. Some are 76 years like Halley's Comet. Some are longer than that. The other comets are called long period comets, where they just come by once and we don't know where they came from or where they're going. Just came by once. Okay? You can't predict those, of course. But short period comets have a life expectancy of less than 10,000 years. They should have destroyed themselves by then. The fragments of these comets that are breaking apart, sometimes the Earth runs through the path of these comets, because the Earth is going around the sun at 66,000 miles an hour. If you're driving your car at 66,000 miles an hour through a cloud of debris, of dust, in a sandstorm, it's going to create all sorts of problems. And the Earth running through this trail of debris in space, it's the same as if it was hitting us at 66,000 miles an hour. We're hitting it. And our atmosphere is 100 to 200 miles thick. It burns up 99.999% of all the debris out there. It acts as a cushion. And so at that speed, the air friction gets up so hot, so fast, it burns them, turns them to ash, and they disintegrate. About 5 fragments a day get all the way through the atmosphere and strike the Earth. Sometimes pretty good sized ones. When they hit the Earth, they can do a lot of damage. You were with me, you saw the Barringer crater in Arizona. Gigantic hole in the ground. Something hit and blew this massive hole in the ground. They say the bottom of the hole is big enough that you could play 20 football games simultaneously. On the sides of this crater, you could hold, I think they said 2 million spectators if you set it up with bleachers. It's about, I think, 7/10 of a mile across, if I recall. It's named Barringer because some guy named Barringer bought it. He bought the property. It's middle of no place, Arizona. He wouldn't want the property for anything else. But he knew that many comets are made of nickel. Nickel is a relatively expensive metal. It's used, they mix nickel in with iron to make gun barrels, because when it explodes, when you fire the rifle or the cannon, it's going to swell and come back. It allows the metal to swell and not stretch. If you just used iron, it would swell, and every time you shoot, it gets a little bigger, and pretty soon your bullet's flopping around in there, and you don't want that for sure. So the nickel is used to give the elasticity, but nickel is a pretty rare element, and the nickel is what is highly, comets contain a high degree of nickel. So Barringer bought this property. He thought, you know, if a comet hit here, maybe it's buried down there someplace. I'm going to dig it up. I'm going to mine it. Have a nickel mine and be able to sell this metal. So they found fragments of nickel all over the fields. As it was coming in, apparently it was burning and pieces are flying off the back of the comet, and then they would cool down and drip. So they find pretty good chunks of nickel all over this field, you know, within a few miles of the crater. He drilled several holes in the bottom looking for the meteor, found nothing, went broke. He had enough money for one more hole, and he was out there with his pistol shooting in the mud, studying, you know, how deep did that thing go anyway, you know, checking the size of a bullet and the speed compared to how hard is the mud. And he noticed the gun accidentally discharged, is the story I heard, at an angle. So the bullet went off at an angle, hit the mud, and made a round hole. He thought, man, if you hit at an angle, it's going to make an oval-shaped hole. No, it made a round hole. He said, wait a minute. Maybe the comet hit at an angle, still made a round hole, but here I've been digging down in the middle of the hole for this comet. It might be buried outside the hole. So he did a bunch of shooting into the mud to see, you know, what it would do as far as, and he noticed one side comes up higher than the other of the lip that lifts up. So he went back and measured the mountains around his crater and found one side's higher. He calculated which way the meteor was going to be coming, and he said, wow, it's probably right out here. He had enough money for one more hole. He went out, drilled down, kept hitting something that kept breaking his drill bits, and went broke. That's where the story stopped. That's the Barringer crater, so there may indeed be something down there. Some people think there's nothing down there. It probably got so hot coming in it broke apart, and it hit like a shotgun. A bunch of little pieces hit. So there really isn't a mother lode. Who knows, okay? But anyway, comets are constantly losing material. This is a fact. Nobody argues with this. And they have a life expectancy of less than 10,000 years. And you can't just keep losing and losing like comets are doing. I tell people it's like your checkbook. You can't just keep losing and losing. If your outgo exceeds your income, your upkeep will be your downfall every time. You just can't keep spending money. But these comets are flying around with this life expectancy of less than 10,000 years. So I mentioned this in my seminars, and one scoffer named Madsen has a whole website devoted just to me. Madsen does. I think that he sent me his book. Several people have sent me his book, How Good Are Those Young Earth Proofs, or something like that. It's funny to read, because just like students I had in high school, you know, they think because they said something, therefore they answered the question, you know. And the more they talk, it's pretty obvious the less they know about it. He probably did essay questions like that, right? Called a snow job, right? Just keep talking and talking. And you ought to read some of the arguments they give, and just go slowly and think about what they're saying. Oftentimes, it's hilarious. Madsen said, here's his answer to my comet argument, okay? He said, based on a study of the orbits of several long-period comets, the Dutch astronomer Jan Oort proposed, that means he guessed, he thought, he hoped, he prayed, that a great shell of comets existed at the remote frontiers of our solar system. Remote frontiers of our solar system. I'll show you what he means by that in a minute. Talk about remote. He said better statistics in more recent years have supported the existence of the Oort cloud and put it at a distance of 50,000 astronomical units. Now this would be a quiz question. What is an astronomical unit? That is the distance from the sun to the earth. If you're going to measure the distance in space, you need a bigger ruler. You don't want to say it's 474 zillion inches, you know, between these planets. You need a bigger unit of measure. So the distance from Earth to the sun is 93 million miles roughly. That is called 1 astronomical unit. Now, we have how many planets in our solar system? 9. Does anybody know the acrostic to memorize the names of them?
My very extravagant mother just something
Sent us. My very extravagant mother just sent us 90 parakeets, which would be dumb to do, but what it means is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. Pluto is the farthest one out. It is 39 astronomical units away. You cannot see Pluto without an extremely good telescope. He is saying these comets are 50,000 astronomical units away. Now, tell me, do you think he's ever seen those things? I don't think so, right? Here's what they say about the comets, because you're going to have to face this, Eric, when you get out there speaking. Somebody's going to say this Oort cloud is where they're coming from. Well, Earth to Sun is 1 astronomical unit. He's claiming this is 50,000 astronomical units away. What would the force of gravity be, considering the inverse square law? How much pull does the Sun have on these comets? Real close to 0, right? Not much, right? Now, no one has ever seen the Oort cloud, of course. This is all theoretical. Oort never saw the Oort cloud. He made it up. He hoped it happened. He thought it might be there, but he does not know that for sure. Now, Oort proposed this in the 1950s. That's what Madsen said. In 1974, there was an article in Astrophysics and Space Science magazine, volume 31, that said, Oort proposed a cloud of comets surrounding the solar system based on mathematical errors. What that means is, there is no Oort cloud. It doesn't exist. But the rest of Madsen's answer is typical of the scoffers. He said, sorry fellas, if you want, he's talking about me, if you want to use the comet argument, it's up to you to prove, beyond a reasonable doubt, that the Oort cloud and other sources don't exist. Now think about what he's saying there. He's saying, if I want to use the comet argument as evidence the solar system is young, I have to prove the Oort cloud doesn't exist. Well, you tell me, how could you prove the non-existence of anything? Why doesn't he prove the non-existence of God? You can't prove the non-existence of anything. And I tell folks, look, if he wants to use my tax dollars to teach all the kids in school the earth is billions of years old, it's up to him to prove it does exist. This is a typical tactic the scoffers use often. They try to shift the burden of proof on you. No, the burden of proof's on him. Here's the facts. We do have comets. They don't last long. 10,000 years seems to be a reasonable estimate for the maximum life expectancy of a short period comet. We still have short period comets. We know they don't last long. They certainly don't last forever. You can't just keep losing material. And the Bible teaches the earth is 6,000 years old. Now that all fits together just fine. So he's got the problem, not me. You will find, Eric, if you listen carefully when they make statements, when they ask you questions, the problem, the solution is in their question, the way they're asking it. Like, don't you believe in evolution? What do you mean by evolution? Well, things change. Well, yeah, things change. Are the changes ever positive? Does the change ever add more genetic information? Never seen that. Does the change ever change it to a different kind of animal? We'll get into more of that later, of how they, when I got a debate tomorrow night, Saturday night in wherever I'm going, Wisconsin. And if you listen to what they're saying carefully, you can pick out, after a little experience doing this, you can pick out exactly what to respond to them. But this guy is saying, it's our job to prove the Oort cloud doesn't exist. This, of course, is ridiculous. This wouldn't hold up 2 seconds in a court of law. Some freshman lawyer would pick that one apart. Yes, sir?
If you think the earth is 6,000 years old, now how old do you think the universe is? The same age?
I think the whole universe is 6,000 years.
Everything 6,000.
Because Exodus 20 in the 10 Commandments, God wrote on a rock with his own finger and said, in 6 days the Lord made heaven and earth, the sea, and all that in them is. Well, if you made it all in 6 days, that would include everything. Heaven, earth, everything. Made in 6 days. So from Scripture, it's very certain that everything was made at the same time. There's no question there. Also, when we look at the evidence from space that we observe, there's no reason to say it's more than 6,000 years old. No reason to say it's billions of years old. The comets don't say that. The star galaxies don't say that. You know, they just all indicate, look, a few thousand years is all we need. Psalm chapter 19. The heavens, notice it's plural. We'll get into that later. Why is it plural? There is more than one heaven. There are 3 heavens mentioned in the Bible. The heavens declare the glory of God, and the firmament showeth his handiwork. The psalmist said, when I consider thy heavens, not if. Now we've got a real problem in this generation because we've got a lot of kids that don't take time to consider the heavens. I tell them, you ought to shut off the TV, shut off the VCR once in a while, and go out and consider the heavens. I remember as a kid, we used to lay out in the yard and look at the clouds and try to see designs in the clouds, you know. Who can see the ships or whatever, you know. And my dad would teach us and Mom would teach us the different kinds of clouds and what does this mean? You know, when you see the cirrus clouds, that means there's probably going to be a front coming through. Probably in a few days you'll have a rain. You know, and you can actually, and Jesus talked about the Pharisees, how they were able to discern the face of the sky. You know, when it's red and lowering, you have a certain kind of weather. But we need to really take time to consider the heavens. He said, when I consider thy heavens. Psalm 39 said, while I was musing, the fire burned. The word muse is only used twice in the entire Bible. The other one is Psalm 143. He said, I muse on the work of thy hands. The word muse literally means to think. That'll be a quiz question. What does the word muse mean? Muse means to think. Now English is a very interesting language. We have a word theist, which means a person who believes in God. Then you put the letter A in front, you get the opposite of. So an atheist is a person who claims to not believe in God. Just the letter A in front changes the meaning to mean the opposite of. The word muse means to think. The word amuse literally means to not think. That's the meaning of the word. They have entire parks where you can pay and go do that. How many have ever heard of those before? They're called amusement parks, right? We have a whole generation that wants to be amused, don't we? They don't want to muse. They don't know how to muse. They only know how to be amused. That's why if you watch the Hollywood movies, they get more violent, more explosions. Got to be something bigger, better than the last time. Just like drugs, you know, a person takes drugs or alcohol or anything like that. They want to get this thrill. Well, after a while, it takes more to get the same thrill. The person who drank 4 beers and got drunk, now he's got to drink 6, you know, and then he's got to drink 10, and pretty soon he's got to drink whiskey, and pretty soon nothing works. And the same with a person who chases thrills all their life. The thrill seekers, they're always looking for something bigger or better. They're being amused. They don't take time to muse. Just go outside and lay on the roof and look at the stars. We used to do that as kids. We'd go campouts, you know. Just go look at the stars for a while. I remember up in Colorado one time, we're up in the mountains. We laid out 3 o'clock in the morning. I woke up for some reason, couldn't sleep. I went out, laid on the picnic table, and saw 300 shooting stars in 1 hour. I still remember that, you know, it's 40 years later. It was awesome. Remember laying in Grandpa's driveway in the backyard in the middle of Arkansas, you know, and seeing the shooting stars going all over the place, scores of them. We need to take time to consider the heavens. Because when you do this, the psalmist said, when I consider thy heavens, the work of thy fingers, the moon and the stars which thou hast ordained, what is man that thou art mindful of him? See, a person who considers what God can do or what God has done is not impressed with what man can do. We see the bodybuilder, you know, he can lift 500 pounds. Well, you should see what God can do with 500 pounds. Right? And we've got an entire generation now that are sports crazy. They can rattle off the top 10 football teams and the top 10 baseball teams, but they couldn't name the 12 disciples. We have a problem, folks. We have an entire generation now that has not learned to muse. The story is told of the prince who was going to become the king when Dad died. The dad called him in. He said, son, I'm about to die. You will be the king. Son, I know you're only 20 years old. I'd like you to promise you'll do one thing for me, would you, son? He said, sure, Dad. Now, the boy was anxious to be king because he was going to party. Man, he's going to throw the biggest party, last the next 25 years. He said, son, I only ask you to do one thing for me. I'm asking you on my deathbed. He said, Father, whatever you say, I promise I'll do it. He said, son, I want you to take the first 30 minutes of every day and do nothing but think. He said, that's all you want? He said, yep, that's all I want. First 30 minutes, no entertainment, just think. He said, okay, Dad, no problem. Well, the first day he thought about all the parties he was going to throw and all the stuff he was going to do, you know, and all that, and he had a day all planned out, and he ran off into the day 30 minutes later. After several days, though, it started getting to him. He sat there thinking, you know, where's this lifestyle going to lead me? If I keep this up, where am I going to be in 5 years? What kind of a king am I anyway? What kind of example is this for my people? And after about a week, he finally got his life straightened out. And we've got an awful lot of kids that don't ever take time to think about where they're going. They're so busy being amused, they don't take time to muse. Since television came into prominence in America, it's gotten much worse. We have a lot of kids, honestly, I told my kids in school, what would happen if you couldn't have any electronic devices, no radio, no tape player, no TV, for 24 hours? It's like, oh wow, I'd die, man. Well, you'd be surprised. You really wouldn't die. You might go through withdrawal for a few days, but you wouldn't die. We didn't have a television in our house for 11 years when my kids were growing up. They didn't have one. I wanted them to learn to muse. I like to see the little kids playing over here in the yard. Kids need to learn to imagine, to make up things. See the kids playing with the trucks and the cars. They have to have, developing an imagination is a vital part of growing up. People who study child development and child growth will tell you, kids that sit in front of the TV from the time they're 2 years old, something's wrong in the way they develop. They're not learning to think. They're learning to be entertained. It's got to affect them somehow. Go out and consider the heavens. According to the book, I think it's Ackerman's book. Is this the one? No, Donald DeYoung's book, Astronomy in the Bible, which I've got in my office. He said it's been estimated there are enough stars that every person on Earth could own 2 trillion of them. Just since part of the course is for Eric's edification here, if you want to learn how to count to big numbers, did we do this before? Million is the number 1,000 with one set of zeros after it. Billion, Latin word bi for 2, has 2 sets of zeros. Mono, million, bi, billion, trillion would be the number 1,000 with 3 sets of zeros. Mono, bi, tri, what would come next? Quad. A quadrillion has 4 sets of zeros. Then quint. If a woman has 5 babies, she has quintuplets. So a quintillion would be 5 sets of zeros. That's 15 plus the original 3, 18 zeros. Latin for 6 is sex. A sextillion is 6 sets of zeros. And then sept, S-E-P-T, for 7. Oct for 8. Nov, N-O-V. Sept, oct, nov. Guess what's next? September, October, November, December. Used to be the 7th, 8th, 9th, and 10th month. And then Julius Caesar decided, I want a month named after me, so he made up July. And Augustus Caesar said, well, I want one for me too, so he made up August, and so that shifted everything down. So September, means 7, is the 9th month. Figure that out. October is the 10th month, but that's how they got the names. But just so you know, a trillion is a lot. If you started counting as fast as you could count, you probably couldn't count to a trillion in your lifetime. 2 trillion stars apiece. That's a lot of real estate we can have. And here people fight over just a few square feet down here, you know. There's plenty coming. Job chapter 12 said, speak to the earth, and it shall teach thee. What can the earth teach us? How old is the earth? The earth is like a big magnet. Now here's where the inverse square law would apply. The strength of 2 magnets, the force of attraction, is inversely proportional to the square of the distance between them. Which is why when you deal with electronics, computers, something like that, if you set a computer right on top of a TV, this could be bad because the TV has a giant magnet at the back that is used to direct the stream that's going across your screen. Stereo systems, any speakers have a big magnet in them. If you get a computer too close to a magnet, you create a problem. But if you double the distance, it's only 1/4 of the problem. So distance is the secret with magnets, or shielding, which they have to forget all that. Anyway, the Earth's magnetic field is getting weaker. Now, since a guy named Gauss, G-A-U-S or G-A-U-S-S, I taught science, not English, but Gauss began measuring the strength of the Earth's magnetic field. How strong is the magnetic field of the Earth? They've noticed since he started doing that, In the last 150 years, the Earth's magnetic field has lost 6% of its strength. If we have lost 6% of our strength in one